All right, so this is what we will be doing for homework. I just want to handle homework out of the way here. So if you do have 1.2 questions, we'll do those real quick here right now. But I don't think we'd have those. Any 1.3 questions, any 1.4 questions, we'll get the list going, then we'll go from there. So anybody, going once, going twice. 15 for 1.3, okay? And then we'll get a list here. So anybody else with questions? Looking at your homework. 49, 57. 49, 57, yep. Should put an H next to it, I guess. Is that okay, like that? Just so we know honors. All right, any others? Going once, going twice. Sold, that's it. Pretty easy stuff. Okay, so let's go with 1.3, no, number 15. And I'm going to do this fast because I know most of you guys, or some of you guys have done it. Some of you guys have questions on it here. So I go super speed. Just slow me down. We're good? If I went number 15 and talk to me just to make sure, is this what we have here? Something looks like that? Is that theta here? And it says there's a dot in here. Anybody know what the dot is? I think it's -6 what? -6, -2? And it says in the diagram below, angle theta is in standard position, which means it starts on the positive x-axis. In this case, find sine theta, cosine theta, tangent theta. Okay. Boom. I need boom, and I need boom. This is 1.3, so we're back to the circle, right? So, I don't know, I have coordinates, is that right? I already know what x is, I already know what y is. That's nice. What am I missing? The r value. Let's move those over. Okay, r value would then be -6 squared plus a -2 squared is equal to r squared. And how about a 36 plus a 4? Every okay with a 40 here? And if you take a square root, how come I don't need to put plus or minus? R's are always positive, is that right? So now 40, root 40, is there a perfect square inside 40? 4, huh? It's 4 times 10, so 4 is a perfect square, so technically it's 4 times 10. Technically, you can separate square roots as long as they're positive numbers, and technically that 4 now turns into a 2. Are we good there? Cool, and then we get to put this back. Love it. Okay, boom, boom. And by definition, sine is y over r. So r is, that's right, here r is a number that's not 1, huh, right? It's other than 1. So yeah, we gotta keep in mind that definition. So everybody okay with a -2 over 2 root 10? And that would be wrong because you gotta reduce the fraction here, right? So how about 2's reduce? And how about a -1 over root 10? Are we good there? All right, and we can rationalize it too, right? We can make a root 10 over 10. We go from there. Okay, how about an x over r for the definition for cosine, and we get ourselves a -6 over 2 root 10. And how about reduce this guy here, 1 and 3, and how about a -3 over root 10? Everybody good there? Sweet. And then tangent, ooh, tough one here. Y over x, how about a -2 over -6, and how about a 1/3 positive? Okay, going once, going twice. Are we good with 15? 1.4, number 49. All right, and then tell me if I copied it down correctly here, because sometimes I have a tendency to mess up on the copying. And then what happens is I do the whole entire problem. Then at the end, then the students say, oh, Mr. NG, that was a 5 instead of a 4. And that's just cruel. I think that's actually cruel. So, okay. So we are in quadrant 4, just kind of be mindful of that. So just notice that we're here. And since we're in quadrant 4, I know the x is positive and the y is negative. True, true. Okay, so 1.4, and Emil, you were not here for this one here. So instead of going back to the unit circle or to the circle definition, we've made all these different connections last time from all these here. So I'll show you the list here afterwards here, but cosine, if we know cosine, what's another one that we know right away, which is its reciprocal? Anybody? Secant, right? Cosine and secant, they're just reciprocals of each other. So all we do is we just write it like this. Boom, boom. So then after that, I think we need some kind of Pythagorean theorem. Which one do we want to use? Yeah, let's do sine and cosine, huh? So sine squared theta plus cosine squared theta is equal to 1. That's the original one, right? The one that we want to use is going to be sine theta is equal to, and then we get to choose plus or minus over here, right? Plus or minus 1 minus cosine. It's just moving the cosine squared to the other side. So now let's put in some numbers and let's think about this guy, plus or minus. Which one do we want? We want the minus. Are we good? Because we are in quadrant 4. That is why. So plug it in. 1 minus, and this guy is going to be a 2 over root 3, 13, sorry, root 13, but we're going to square it. So I'm going to run out of room here pretty soon here, but I'm going to go like this. If I square the 2, it becomes a 4. If I square the root 13, it becomes 13. I got to pause there for a little bit because I need to go on to the next slide. Let me guys catch up real quick here. So this is all inside the square root, right? We need common denominators, which are 13 is good. Okay. So can I keep on going here? I'm going to say like this, negative, and 13 over 13 minus 4 over 13. Is that right? Makes a 9 over 13, and Mr. Grant taught us that I could split this little guy into 2 different pieces. And then a 9 sitting there is going to be actually a 3 on top, and 13 is not a perfect square, so that is my sine theta. Cool. Once I know sine, I also know cosecant. It is the reciprocal, so careful here. The negative just stays out in front. How about a root 13 over 3? Done. Connection. Next, I'm going to go with tangent. We good? Tangent theta is going to be sine over cosine. That's cool. And I got myself a negative 3 over root 13. And originally, anybody remember originally? I think it was 4. Is that right? 4 over root 13? 2 over root 13? Yes, yes, yes. Thank you. Yeah, that's the kind of help that I like. Thank you so much. 2. Okay. And then perfect. Yeah, so denominators will cancel, right? Denominators of complex fractions go away. And this guy is a negative 3/2. Once I know tangent, I also know cotangent. And the answer is just the reciprocal. So how about a negative 2/3? Are we done? Love it. Okay. Next, next, next. 57, 1.457. Honors. All right, says use a calculator. Oh, wow, we did not even talk about calculators, right? Not in the lecture from the other day. This is a negative 1.24. And theta is in quadrant 2. Boom, 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 boom. Round the answer to the nearest hundredths. Find the remaining trig functions here. So here we go. So honor students, this is really for you guys here. You figure like, what? I'm supposed to extend my knowledge? We never did calculators. Shouldn't you? You're just messing with us. That's not cool. And Maddie, can you close the door? What? It's a calculator. It's a big calculator. So now, do you need this calculator? What? It's the same thing as Wyatt's calculator here. Da 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 da. Say again. Does it work? It better work here. Let's see. So we have to go to the nearest hundreds place. If I know secant, what trig function do I know already? Cosine. Cosine is going to be the reciprocal of this. So we got to go to our calculator, and we're going to go 1. Now I know it's negative. True, true. I just need to know what the value is. 1 divided by 1.24. Boom, boom, boom. Nearest hundreds place is 0.81. Yep. Huh? So 0.81, and it's wrong. How come it's wrong? It's negative. Okay, are we good there? Now I need to use a trigonometric identity. Still gonna use sine and cosine. We good? That's just like the easy one. That's the one that we'd use most often, like approximately 92.78% of the time. And so we still want the exact same thing. We want the sine is equal to plus or minus. That's the version that I want. Absolutely. Yeah. Okay, so we are in quadrant 2. So question is positive or negative? We want positive. That's cool. Okay, so maybe over here next to this, maybe we should just kind of do this here. Since we're in quadrant 2, just to remind ourselves, we got a negative x, positive y, right? For quadrant 2. Yeah, so cosine uses x, so that's why this guy's negative. Sine. No problem. And then you don't have to if you guys are so sophisticated like that. But I just put a plus sign over here just to remind myself I did think about it. And the fact that I am going to do that. So in a calculator, let's punch that in. Okay, so full disclosure, can we do full disclosure here? I made this in 2005, this app. It was so fun, super geeky. I had to put, I forget already, I think it was 3 different programs together, right? You had to get a program that simulates the activity of a calculator, right? Then you actually had to get the software of the calculator, and then you had to find the skin for the calculator, right? So this stuff here. So it took me all summer long. It was a fun project. And I put it together. You know, like when you're really, really happy about something, like, yeah, that was so cool, I accomplished it, right? And then 2 months later, TI came up with their own emulator for the calculators. so it was fun though. It was fun putting it together. So I still like using this one because it's like it's mine, you know. I built it. So let's go with it here. So square root, right? That square root was 1 minus. Oh boy. So I'm gonna put. I guess I should. Yeah, I should put another parenthesis, right? 1 parenthesis is for the square root. And don't forget. I think you guys know this, right? Here. So this guy here is your negative button. This guy is your minus button. Those are 2 different buttons, right? This one here is an operation called subtraction from something. And this guy's the negation of a number. So I want that one. So 0.81. Now your answer, 2 different ways to square. You guys were good? You can square this button right here because we use squares all the time. If you press this button, you get yourself that. Or what you can do is you want any kind of generic square that you put this guy. It's called the caret key. Spelled like caret as far as like diamonds are concerned, right? C-A-R-A-T, right? Not C-A-R-R-O-T, not the orange thing. Okay. True. Okay, so, and that's the fast way to do it here. Okay, and then don't forget we have to close off our square root as well, right? Boom, boom. And we get ourselves the answer, I think. Help me out. Answer is? Okay, and then a trivia question for you guys. How come I am able to use an equal sign when this is only an approximation? Ooh, trivia. Do-do-do. Do-do-do. Super close, Megan, super close. So, yeah, so I rounded off, but I'm saying the answer is 0.59. No, that's a no on that one. Okay, Karis? Perfect, yeah, because instructions on the homework says I want you to find it to the hundredth place. So this is actually the exact answer to the hundredth place. Good? If it did not say that, then you'd have to say approximately 0.59. Okay, so sine. Once I know sine, I know cosecant. And that one, again, going over here, that's going to be 1 divided by 0.59. Doom, doom, doom. And 1 point, whoa, hold on, let's go over here. What do you guys say? 1.69 is good by me. Okay, next. Let's see, what do we have next? Next. Oh, tangent would be next, right? Or cotangent. Doesn't matter which way you go. What else did I want to say real quick here? Oh, notice real quick here, just for you guys here. So notice on the first time that we ever did this. On the first time we ever did this, we did 1 divided by 1.24. And it was not 0.81, right? It was 0.80645, right? So on the homework, if you're off just by a little bit, a hundredth place or 200th place, it's because we did not use our original number to do the rest of them. Okay? Does that make sense? Because we're just rounding as we're going. That's the problem. So, okay, so, and that's okay. That's okay to round as we go because we're just learning the identities. We're not trying to learn exact precision here. We'll learn that as we do applications. Okay, tangent is going to be, gotta go back over here, sine over cosine. Anybody give me the approximation for, and I'm doing this properly, right? It's the sine of some kind of value called theta, right? Sine of theta, cosine theta. Okay, guy's not going to talk to me. Okay, fine, I'll do it. Thank you. 0.59, 0.81. Is it negative 0.81? Okay, thank you. All right, calculator time. Ooh, yeah, say again, Gareth. Perfect. So here it is. Yeah. So as I'm punching in the numbers, right? Because I'm just punching in numbers for now, right? So because cosine was the negative, it technically would go here. But as I do the problem, when I finish this off, it better be here somewhere in front, right? Okay, are we good there? And last one, cotangent. Okay, and then on the calculator also, the fun part, if you do not want to round, you guys know this, is that true? You guys used calculators last year, right? Yeah, because we technically started using calculators in Algebra 2. So, okay, how about 1 divided by, and then you can go down over here called ANS, called answer. So second answer, and then you can actually, it'll just copy this whole thing over again, so you don't have to punch it in, especially digits that long. And how about a 1.37? We're good. Anybody finished off this one? Is this the answer that the back of the book gave, or we are off just slightly? Ooh, thank you. Thank you again. Okay, sorry, Karis. Is this the answer the back of the book gave? Exact, or are we off sometimes by a hundredth place? Oh, cool. We are super cool at that. Okay, are we good there? Boom, boom, boom. Okay, next is any other homework questions? Going once, going twice. Okay, so here's what we're gonna do the rest of the time. I'm gonna pause the recording because there's no reason for it to record it. We're going to do something that looks like this. What? And so